We've all heard Minecraft worlds are infinite, but here's the thing. They're not. At least not in the way you think. In reality, Minecraft is a carefully orchestrated illusion built on procedural generation, noise functions, and a massive coordinate system. Welcome back to PandaProgramming. Today we're looking into Minecraft. This video will teach you everything you need to know about Minecraft's code. So without further ado, let's dive right into it. Here's where our journey begins. Minecraft generates terrain on demand as you explore. That's why it feels infinite. The game does not store an entire planet worth of blocks in memory. That would be absurd. Instead, it generates chunks, which are tiny slices of the world that measure 16 by 16 by 16 blocks and stretch from bedrock to sky. When you walk toward unexplored territory, Minecraft's engine looks at your position and generates new chunks just ahead of you while unloading chunks you've left behind. It is like walking through a movie set where the scenery is being built seconds before you arrive and dismantled the moment you leave. And here is the genius part. Every single chunk is not randomly generated. If you walk away from a chunk and come back later, it looks exactly the same. Trees, caves, mountains, everything stays consistent. That is because Minecraft uses something called a seed, a single number that acts as the DNA for your entire world. Think of the seed as a master key. Feed that number into Minecraft's generation algorithm and it will always produce the same world down to the last block. This is why you can share seeds with friends and explore identical landscapes. It is not magic, it is deterministic chaos. Now let us talk about how those chunks actually get created, because this is where things get beautifully weird. Minecraft does not just scatter blocks randomly, it uses something called Perlin noise, a mathematical function invented by Perlin in the 1980s because he wanted to make computer graphics look more natural. Perlin noise generates smooth, organic-looking randomness. Imagine a landscape made of rolling hills instead of jagged spikes. When Minecraft generates terrain, it runs multiple layers of Perlin noise at different scales. One layer determines the overall height of the terrain, creating mountains and valleys. Another layer adds smaller details like hills and slopes. A third layer might control where biomes appear, deciding whether you get a desert, a forest, or a frozen tundra. The game stacks these layers on top of each other, combining their outputs to produce terrain that feels natural and varied without ever repeating in an obvious way. But here is where it gets even more interesting. Minecraft does not generate everything at once. It uses a multi-step process. First, it decides the biome layout using a grid system. Then it generates the basic terrain height. After that, it carves out caves and ravines using additional noise functions. Finally, it decorates the surface with trees, flowers, and structures. Each step builds on the previous one, transforming a blank chunk into a fully realized piece of the world. And all of this happens in milliseconds, which is why you can explore Minecraft without the game constantly freezing to generate new terrain. The caves are particularly clever. Minecraft uses three-dimensional noise functions to carve out underground spaces. Imagine a cloud of invisible density values floating through the ground. Wherever the density drops below a certain threshold, the game removes blocks, creating tunnels and caverns. This is why Minecraft caves feel organic and interconnected, rather than looking like someone just punched random holes in the ground. Here is where the infinite myth completely falls apart. Minecraft's world is not infinite, it is just extraordinarily large. The game uses a coordinate system where every block has an X, Y, and Z position. The center of the world is 0, 0, 0. From there, you can travel in any direction along these axes. The maximum coordinate you can reach is 30 million blocks in any direction. That gives you a playable area of 60 million by 60 million blocks, which sounds infinite until you do the math and realize it is just a really big square. But what happens when you reach 30 million blocks? This is where it gets hilarious. In older versions of Minecraft, before Mojang patched it, you would encounter something called the Farlands. This was a glitchy, nightmarish region where the terrain generation algorithm completely broke down. The Perlin noise function started producing absurd values because the numbers got so large that floating point precision errors kicked in. The result was a chaotic mess of towering walls, impossible overhangs, and structures that looked like the game was having an existential crisis. Players used to make pilgrimages to the Farlands, walking for real-world weeks or even months to reach them. Some even live-streamed the journey. It became legendary in the Minecraft community. Mojang eventually removed the Farlands by adding a hard boundary at 30 million blocks. Now, if you try to walk past that point, you just hit an invisible wall. The game does not even generate terrain beyond it. You have reached the edge of Minecraft's universe, and there is nothing but void beyond. Let us talk about why Minecraft does not just generate everything at once. The answer is performance. If the game tried to load and simulate every chunk in a 60 million by 60 million block world, your computer would melt into a puddle of silicon in regret. Instead, Minecraft uses a render distance setting that controls how many chunks are loaded around you at any given time. Set it to 16 chunks, and the game loads a circular area of about 500 blocks in every direction. Set it higher and you get a larger view distance but also more lag. Behind the scenes, Minecraft divides chunks into different states. Some chunks are fully loaded and simulated, meaning mobs move, crops grow, and redstone circuits function. Other chunks are only visually loaded, meaning you can see them but nothing inside them is actively updating. Chunks even farther away are completely unloaded, existing only as saved data on your hard drive. This layered approach lets the game balance visual fidelity with performance, ensuring you can explore smoothly without the engine choking on too much data. And here is a fun detail. When you place a block or change something in a chunk, Minecraft marks that chunk as modified and saves it separately. This is why player-built structures persist even after you log out. The game is not regenerating those chunks from the seed anymore. It is loading your customized version from disk. Essentially, you are overwriting the procedurally generated landscape with your own data, one block at a time. But how does this system work for auto-generated structures? Structures like villages, temples, ocean monuments, and strongholds follow similar rules as terrain. These are placed using a separate algorithm that divides the world into a grid and decides where specific structures should spawn based on the seed and biome conditions. The game essentially plays a lottery for each grid cell. It checks if the biome is correct, if there is enough space, and if another structure is not too close. If all conditions are met, it places a pre-designed template into the world. This is why you can find a village that looks almost identical to one you found 3,000 blocks away. They are not procedurally generated like terrain. They are copy-pasted from a library of templates. The game just decides where to put them. Strongholds are even weirder. Minecraft generates exactly 128 strongholds per world, distributed in rings around the spawn point. Their locations are mathematically calculated from the seed, which is why speedrunners can use tools to predict exactly where strongholds will appear before even loading the world. The game is not hiding them randomly. It is following a strict formula, and if you know the math, you can crack the code. Now here is what makes Minecraft fascinating. Despite all this technical complexity, the core idea is almost stupid in its simplicity. Take a number, run it through some noise functions, stack a few layers together, and boom, you have a world. But because the game does this at such a massive scale and with such careful tuning, the result feels magical. You are not exploring a handcrafted level designed by artists. You are wandering through a mathematically generated landscape that exists because an algorithm decided it should. And yet, players form emotional connections to their Minecraft worlds. They build cities, create stories, and remember specific mountains or valleys. the game does not care. It has no concept of your favorite spot or the house you spent hours building. To Minecraft, every block is just a number in a three-dimensional array. Every biome is just the output of a noise function. Every chunk is just data waiting to be loaded or discarded. The emotional weight, the creativity, the meaning, that is all you. Minecraft just provides the canvas. It lets you paint your own creativity on top of its mathematical foundation. And with that, we have come to the end of today's video. If you've learned something new about Minecraft today, smash that like button and comment what games we should explore the code of next. Thanks for watching. We will see you in the next one.